Equivalent ratio problems can be solved by building rectangular arrays that clearly show the ratio. For example, in a bucket, there is a ratio of 2 blue chips for every 3 red chips. There is a total of 30 chips in the bucket. One set of 2 blue chips and 3 red chips can be organized in a pair of rectangular arrays. This set represents a total of 5 chips. Additional sets of 2 blue chips and 3 red chips can be added to the arrays until there is a total of 30 chips. Notice that the original ratio of 2 blue chips for every 3 red chips holds for these 30 chips, 12 blue and 18 red. So, we can say that the following ratios are equivalent because there are 2 blue chips for every 3 red chips in both ratios. The rectangular arrays can also be used to find other equivalent ratios. These equivalent ratios can be organized in a ratio table. Both values in a ratio can be multiplied by the same value to get an equivalent ratio. For example, 2 blue chips can be multiplied by 6 to get 12 blue chips, and 3 red chips can be multiplied by 6 to get 18 red chips. In the rectangular arrays, this process can be understood as finding the number of chips in 6 copies of the column of 2 blue chips and 3 red chips. If both values in a ratio of 6 blue chips to 9 red chips are multiplied by 3, the equivalent ratio of chips is represented by 3 copies of 6 blue chips and 9 red chips. Notice that multiplying in the ratio table and copying in the rectangular arrays both result in an equivalent ratio of 18 blue chips and 27 red chips. Note, both values in a ratio can be divided by the same value to get an equivalent ratio. In this example, division can be understood as reversing the process of multiplying.